Hi guys, good morning. My name is Joy Kaihe and
Genros Canoos.
in this video, we are report the identifying the appropriate rejection region for a given level of significance. In this video, we will going to learn about the test direction, rejection region, and level of significance, which are very important in making decision about the claim or hypothesis. Recall that the normal curve involved from the probability distribution whose area is equal to 1 and has become the mathematical model in hypothesis testing.
The areas are the probability values we need for decision making.
Here are the graphical representation of the two-tiled and one-tiled test.
On the diagram, the shade of portion are rejection region and the non-shade portion of the normal curve, the acceptance region. On the first figure on the top, this is the non-directional or two-tailed test, where alpha over 2 in the left and at the right.
Are the rejection level and the acceptance level is represented by the 1 minus a portion. The next two graphs represents to the directional or one-tailed test. On the second figure, the rejection level is at the right represented by alpha at the non-rejection level, or the acceptance level is the same represented by 1 minus a. The same on the third figure, the rejection level or portion is at the left represented by alpha, and also the 1 minus a is the acceptance level. For those who are asking how to determine directional or non-directional, to determine the directional and non-directional, simply examine the alternative hypothesis.
First, if the alternative hypothesis or the age of A uses not equal symbols, then the test is non-directional or two-tiled. Second, if the alternative hypothesis utilizes less than, then this is one-directional, it is one-tailed, and it is to the left. And third, if the alternative hypothesis utilizes greater than, then the test is one-directional, it is one-tailed on the right.
Of the distribution. And here are some keywords to denote direction. Right-tailed, greater, increases, augment, advance, efficient, improves, effective, and more.
Left-tailed, lesser, decreases, diminish, delayed, fewer, ineffective, and more.
And now let us apply those information mentioned. Example 1. A baker claims that the cake he developed and fortified with vitamin A. The non-hypothesis that donated by H of O, that development bread is not different with other brand. The alternative hypothesis by H of A, the developed bread is fortified with vitamin A. Next, let us examine the alternative hypothesis. It's you utilize the symbol because of the word fortified, that means add or enrich. After examining that alternative hypothesis, we will now come up to a decision. The test is directional or one-tailed in just because it's greater than, it is on the right tail of the normal curve.
Example 2. The combination of fruits provides the minimum daily requirement for vitamin C. The non-hypothesis or H of O, the amount of vitamin C is equal to the daily requirement. The alternative hypothesis or H of A, the amount of vitamin C is not equal to the daily requirement. Let us examine it. And we notice that it utilizes not equal symbol. Just because of that, we will now come how to the decision. The test is non-directional or two-tailed.
In making the decision, kindly use the following table to determine types of errors and their probability.
Type 1 error will be presented by alpha and type 2 errors will be presented by beta.
And now presenting to you the table. If you reject a true null hypothesis, it is a type 1 error. Its probability is alpha. If you accept a false null hypothesis, it is called a type 2 error. Its probability is beta. If you accept a true null hypothesis, it is a type A. Its a probability is 1 minus alpha. If you reject a false one, hypothesis, it is a type B, its a probability is 1 minus beta.
Errors can be controlled by assigning small probability values to each of them. The most commonly used probability values for alpha and beta are 0.5 and 0.1 or the 95% and the 99% confidence level.
Okay, let's proceed to our main topic. Rejection region, also called critical region, refers to the region under the normal curve where the value of the test statistic lies for which the null hypothesis will be rejected.
It means if the computed statistic lies on the rejection region, then we reject the null hypothesis. But if it found outside the rejection region, we do not reject except the null hypothesis.
Again, on one-tailed test, alpha is the rejection region. On two-tailed tests, alpha over 2 are the rejection region, while 1 over A, the non-shade, are the acceptance region. And this is now the table for critical values for Z statistic. For your correct decision, on the table, significance level alpha, represented by decimals, confidence level 1 minus alpha represented by percentage and the respective values. For one-tailed to directional, for two-tailed non-directional values. To use the table, for example, for 0.10 or 90%, the one-tailed directional value is 1.28 for right-tailed
And negative 1.28 for left tail. For two-tailed tests or non-directional, 1.64 and negative 1.64 are both critical values. They seem significance level 0.5, 0.3, 0.2, and 0.1. They show that for non-directional, we have positive and negative sign for the rejection region found on both tails of the distribution. For direction test, we have positive for the right-tailed and negative in the left-tailed test.
Again, my name is Desijoy Gaihe and
Generous Canoos.
that's all for today's video. Thank you for watching. Bye!